All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to be continuing learning about polars because I have been making a bunch of progress since yesterday, between yesterday and today, and I've gotten a decent understanding of how things are working behind the scenes, why exactly polars is as fast as it is. And also, I've gotten a little bit of experience, a little bit of extra knowledge, let's say, than what I had yesterday. Because after yesterday's stream, I decided to tell Gemini to generate five. Actually, what I did is I booted up Ubuntu on this laptop that I'm streaming from. Currently, I'm on Windows, and the other machine that you're seeing in the background, so the matrix rain and the terminal window in the top right and in the bottom right, those are running on Linux on a different machine. They're running on Ubuntu, and then that's being streamed over to my Windows machine, where OBS is then streaming it to Twitch. And my VTuber application and the browser that you see at the bottom, in the bottom left, those are also running on Windows. Anyways, I also have Ubuntu running on. I also have Ubuntu installed on this Windows laptop, and usually after I'm done with my stream, I I boot into Ubuntu on this laptop so I can do whatever Linux stuff I want to do. And yesterday, after the stream, I booted into Ubuntu and um, I asked Gemini. So I gave Gemini a sample of these records. Actually, I don't remember if I gave the sample or if I gave that data frame creation code itself. I think I gave the data frame creation code because it was still in that small form with like 4 records. So I gave that block of code and I said, I have this code, I'm learning polars. Can you instead make this code generate around 100 rows? And Gemini did that. It gave me, it generated the code to generate these rows. So, oh, we are dropping frames. Hold on, I need to pause any possible things that might be putting a load on my connection. Okay, I think we should be good now. It was a small frame drop. Okay, okay. What was I saying? Damn, I lost my train of thought. Oh yeah. So I asked Gemini to generate the code to generate, around 100 records, and instead of hard coding, instead of generating the data itself, what Gemini did is it created the logic to generate the data. So it created the code, it generated the code that I could use to generate uh, the data. So there was like a bunch of, random logic in there to help generate this data. And then I generated that and I figured, okay, now within this conversation itself, now Gemini knows that, okay, this is the data that I'm working with. So now what I can do is ask, actually, I can't remember. No, hold on. I mean, it's not going to make a difference, but like, I can't remember if I did it in that same conversation or if I created a new conversation and gave Gemini samples of the records. It was one of the two. Regardless of which one it was, at some point Gemini knew that, yeah, this is the kind of data that I'm working with. And so based on that, I asked Gemini to give me 5 exercises to do. I told Gemini exactly what I've learned so far, which was I learned about very basic expressions, very basic expression functions like call for column and is between. and a couple of other expression functions. And I also told that I learned about contexts, specifically the select with columns and filter contexts. And I think maybe there was one more thing that I felt the need to specify that I know, because I wanted Gemini to be clear about exactly what I know so far, so that the exercises that it gives me, they are limited to that scope, and they're not going into something that I don't yet know. And that turned out to be a good thing, because what Gemini did is, Gemini gave me exercises, because like, okay, we haven't touched the group by context yet. We're gonna be doing that today, but we haven't touched group by yet, and so I don't know group by yet. So I didn't want Gemini to give me that in the exercise, and Gemini didn't do that. Instead, it stuck with select and with columns and filter. What Gemini did is it gave me exercises, and it said, okay, you need to do so and so thing. You need to write your code so it accomplishes so and so thing. Like, let's say um, filtering out rows where height is between this and that, or filtering out, or maybe creating a new column that contains so and so info, or splitting out the names. So like within these names, if you look at the names here, these names they follow the format of first name and last name. So Gemini said, okay, split these names into two separate columns, which are first name and last name. This is actually how I found out, and this is a great thing. Throughout these exercises, I actually got to learn stuff. Like, for example, there was one exercise where Gemini said to check if the birth date is prior to or after, so before or after the year 2000. So if their birth date is before the year 2000, we can classify them as adult, and if it's after 2000, we can classify them as a minor. Which, I mean, we are in the year 2026. That example, like, it doesn't make sense, but like this was just Gemini's way of giving me an exercise. So like we understand that, yeah, um, someone born in the year 2000 would be 26 years old right now, but like just for the sake of an exercise, it gave me that date. Okay, so through that, I learned that through that, and actually a couple of other things, I learned that we can do stuff like, okay, let me actually show you. So I did something like this. Okay, result equals df.select, and then we can give the name, and birth date also. Okay, we can give the birth date as well, and additionally we can have a status column. That's where we specify adult or minor, and in here we do, what was it? Was it pl dot when? Yeah, pl dot when. So through this we can specify an if else condition. So in here we specify the condition that, what was it? PL date? No, not PL date. PL call birth date. If it is greater than PL date, so here we specify a date, 2000, and so 1st of January 2000. So if the birth date is greater than this, then the value is actually, in here, I believe it's supposed to be, yeah, this is also supposed to be an expression. So we need it to be a literal, because it needs to be a string value. Okay, so then the person is, wait, what is this? Birth date is greater than 2000. Greater than 2000 would be classified as minor. Again, 26 years old, like if we are really calculating it, but like just for the sake of an example, we've chosen 2000, and we are saying that, okay, anyone born before 2000 would be classified as adult. Anyone after 2000, classified as minor. It's for the sake of an example. So if the birth date is greater than this date, then we classify them as a minor. Otherwise, um, otherwise we classify them as an adult. Yeah. So I found this really interesting because this allows us to create like an if-else condition to set the value for this thing, right? And the result is over here. Actually, I think I only want the first like 10 rows. What did I just do? Oh, I'm supposed to go backwards. Okay. I accident I accidentally opened up my Twitch VODs folder. This is all my downloaded VODs that I'm uploading bit by bit. But yeah, so these are our results. And as you can see, some of them have been classified. Well, one has been classified as a minor in here. There are 100 rows. So like I could print out the entire thing. Dude, I wonder if I can pass this table into... Yeah, hold on, hold on. I wonder if I would be able to pass this table into tab U. How would that work? Because the thing is, wait, there's a lot of stuff here. Okay, let's get rid of a bunch of this. Oh, no, let's not get rid of that. I just remembered. Okay, so we're going to save this and then print out the result here. And then let's try passing it into TW. That did not work. No, that did not work. Could I pass this out as... Oh, CSV? I could, yeah, wait. Hold on. I need to ask Gemini how I would write this data out to standard out. I'm learning polars in Python. I'm wondering how I can write a data frame in CSV format out to std out such that I would be able to pipe it into another application like tab U maybe to view the CSV data. Okay, that's a great way to handle data, keeping things in the terminal and using pipes as a peak developer productivity aesthetic. Okay, in Polar's most write methods expect a file path or a file-like object. Since stdout is essentially a file-like object in Python, you can direct the output using the sys module. So using sys.stdout. The most direct way to do this is to pass sys.stdout wrapped in its underlying buffer if needed. Wrapped in its underlying buffer if needed. Though Polars handles the text stream well, okay, to write, no, to the write CSV method. Okay, let's try this. Let's test this out. We are gonna add, so import std, no, sys.std, no, what? Sys, okay, all right, whatever. We're gonna print out std out. This says it's a text IO thing. Will this even print properly? I don't know what this is gonna print out. It says it's a text IO wrapper. I need to understand this. Okay, why this works for piping. When you run this script from your terminal, the CSV data is printed to the standard output stream. You can then pipe it into tabu, just like any other command. A few pro tips for pipes: silence logs. If your script has print statements for debugging or logging, this will also go to standard out. That makes sense. And likely break the CSV formatting for the next tool in the pipe. Use std error for logging instead. Oh, I didn't know you could specify a file kind of thing in. Yeah, that is interesting. I don't think I've ever like specified a file stream to write to. I mean, aside from when I'm actually, you know, writing to a file or reading from a file, then yeah, file streams are involved. But I'm not like explicitly creating or destroying the file streams. All I'm doing is wrapping the entire thing into a with context, and Python just handles everything else. So it does all the cleanup for me. Okay, performance. For massive data sets, writing to std out is generally slower than writing to a flash drive or NVMe because of the overhead of the terminal emulator slash pipe buffer. But for viewing data in Tabu, it's usually negligible. Okay. Binary versus text. If you ever need to write a format like Parquet or IPC to std out, you must use. Oh, so if it's binary data, then you should use a buffer so that it won't be interpreted as text. But if it's text data, then you want it to be interpreted as text, and so you write it out as regular text. This is interesting. Okay, okay, wait, no, I need to continue this conversation. Wait, help me understand how that whole std out situation is working from Python. I didn't even know that was an option. Also, I didn't know I could pass it into print. You also mentioned something about wrapping it. I didn't understand that. Okay, all right. Now, while I'm getting that response, um, here's what I'll do. Oh, yeah, this was supposed. Wait, no, you know what? This was supposed to be for like the print statement, right? Oh, no, no, no. I want the thing to be written out to. Yeah, yeah. Okay. So we're gonna do result dot write. Yeah, write CSV. Um, write CSV std dot sys out, not std. What is it? Sys dot std out. And we should be good. So if I pass this into tabu, no, we have a problem. What's the problem? That's weird. Also, where exactly is the issue arising? Okay. All right, so this prints it out. This doesn't. Okay, this could be IO str or IO bytes. We seem to be having an issue here. Wait, what am I doing? Oh, yeah, okay. Um, what did Gemini do up here in the example? Write CSV to std out. Okay, select returns a data frame. Yes. So CSV should work fine. Um, oh, could it be that there's this extra data as well? Maybe it's because of this extra data. Yes, yes. So now, oh yeah, yeah, it was the extra data. So this should instead, as Gemini had suggested, this should go into std dot not std sys dot std error, and yeah, now we are good. So this is our new data frame. I combined that into data set. Okay, our new data frame or data set. That's great. That is awesome. And we learned something new here. Something that I'm definitely going to be looking deeper into. One, because I'm interested in being able to write out to specifically std in, std out, and std error. This is also a thing on the Rust side where so I was having another conversation with Gemini because I was curious about how BAT, which is it's a Rust-based application similar to Cat, but with like more features and niceties and stuff. What was I saying? Yeah, BAT has the ability to recognize when it's being written out to, uh, or when it's being piped, essentially. So it can recognize that, oh yeah, it's data is going to be written out to, it's going to be piped to a different application, and which is kind of interesting. I should look into how BAT is able to find that out. Either way, when BAT notices that its output is going to be piped to a different application, it only pipes the output, um, as in the actual output, that was sort of the meat of the output, and it doesn't pipe all of those extra, like, how do I explain this? So like, okay, I will pipe this over to BAT. So if you look at the CSV here, you'll notice, yeah, we have the CSV data, right? But then there's also this border sort of thing that gives it a nice aesthetic. You guys can't see the full thing right now, but at the top it says std in. So there's above line number one, there's another sort of bar, two lines actually to make up the bar, and it says std in, and then there's this sort of margin line on the left side, and on the left side of that there's these line numbers and stuff. So there's a bit of like formatting and decorative kind of behavior within the output. And when BAT notices that you're piping this into something else, it gets rid of all of this decorative stuff, and it just pipes the main meat of the output. So that's why you're then able to do something like this. So I've piped this from the Python script. This is a useless pipe, but I was just doing it for the sake of explaining. You So like over here we have piped the output from the Python script to BAT, and from BAT to tab U. Give me a second. I just remembered that I forgot to switch. No, I forgot to open up my stream on my phone. Uh, More specifically, I forgot to open up my chat on my phone. But dude, I'm so glad that I've been learning more about polars, and I'm gonna continue doing this off stream. This is probably gonna be the last. Polar's stream that I do. Further from this point, we're going to continue working. We're going to continue learning Godot with Rust, and we're going to continue working on the content pipeline. These are two things that I need to actually, let me write it down here. Stream future things. Actually, let me date this as well, just so I remember it. So 13th March 2026. Give me a second here. Let me open up my chat on my phone. Okay, all right. So in here, I want to add a couple of things. Finish Polar's Python. Today is the last day to stream it. Then continue learning Godot plus Rust on stream, and then continue working on content pipeline, both on and off stream. Okay, that's done. That is saved. And now let's go back here. Okay, all right. So sorry, zoned out. Okay. What was I doing? I was testing this out and reading Gemini's explanation about this. Okay. It's a bit of Unix. It's a bit of Unix. It's a bit of Unix magic. Why did I get stuck on that? Okay, it's a bit of Unix magic that sits under the hood of almost every programming language. Think of your running Python script as a factory with three main pipes. Oh, it's going to explain the std in, std out, and std error. With three main pipes attached to it, the three standard streams. Every time a process starts, wait, OBS just froze. I love how I'm talking about a process starting and my process is freezing here. Okay, I think we are good now. Okay, every time a process starts, the operating system automatically gives it three communication channels. STD in, this is the pipe where data flows into your script, usually from your keyboard. STD out, the pipe where data flows out of your script, usually to your screen. And STD error, this is a separate output pipe specifically for error messages, so they don't get mixed up with your actual data. How print and std out relate? When you type print hello, Python is actually doing a shortcut for system.stdout.write. Really? I didn't know that's a thing. Hold on. Let's test that out. Okay, std. Actually, we can now do this as well, right? We can comment that out. Okay, sys.stdout.write. I didn't know. Holy shit, dude! I didn't know this was a thing. Okay, and here we print out hello. Oh, get rid of bat. Right, there we go. And we have write, and we have write lines as well. So wait, write lines doesn't include the new. Oh, that's why the example mentioned the new line. I was wondering why the example is mentioning the new line. Let's add that in. Yeah, there you go. Python, not Python, print. Print print probably adds the new line for us. Okay, the print function has a hidden argument called file. By default, it's set to std out. That's why you can do print hello world, um, which is the exact same as print hello world file sys.std out. Because Polar's write CSV method is designed to take a file-like object, and sys.stdout acts as, my god, words, sys.stdout acts exactly like a file you've opened for writing. Polars just pours the CSV text into that pipe. Wrapping and buffer mystery. This is where it gets slightly technical, but very useful. In Python, sys.stdout handles text, which is strings. However, some data formats are binary, which is bytes, not text. CSV is text, so you can use sys.stdout. Parquet or Excel are binary. If you try to write them to stdout, Python will crash because it's trying to send raw bytes into a pipe expecting letters. To fix this, you use the buffer. Sys.stdout is a text layer which decodes the bytes into strings. Sys.stdout.buffer, this is the raw layer which sends bytes directly. Rule of thumb, writing CSV, use df.write so-and-so. Writing Parquet to a pipe, use df.write Parquet. Sys.stdout.buffer. Okay. Visualizing the pipe. When you run Python script so and so, the operating system takes the stdout pipe of Python and physically plugs it into the std in pipe of tabu. It's like connecting two garden hoses. Python is pumping CSV data out, and tabu is sitting there catching it. Okay. I would like I'm not going to continue reading this on stream now, but I'm going to leave this conversation open because I want to continue talking about this with Gemini later on. So I'm just going to type out my question here and let Gemini answer it, and then I'll move on to learning more polars, because what's it been like 32 minutes now 33 minutes. It's been 33 minutes. So we're gonna jump into polars. Let me finish asking this question, and then I would like to get a better understanding of that whole file like objects situation. Like, how exactly are these, wait, like what exactly are these streams, and how exactly are these streams being how exactly are these streams being treated like file like objects? So the thing is, right, I'm really wondering how this is happening on a higher level, because I know that on Linux based operating systems, a lot of things are often files. So like various different things, even like devices connected to the uh, even various devices that are connected to the machine, various stats, various like CPU related things, memory related things, a lot of information that you're trying to get. It's going to be in like different files. That's how a lot of Linux based OSs usually operate. That's how they work. Everything is a file. That's kind of their. Oh, you know what? I can pass this in as well. Um, Now, I use Linux, Ubuntu specifically, but I'm also wondering how this works on the Windows side. And also, I would like to get a better understanding of the whole everything is a file motto on the Linux side, because I feel like maybe that might have something to do with this. Okay, so I'm not going to continue with this conversation. I'm going to let Gemini give the answer, and we are going to continue learning polars. We're not doing the window function or window functions, because apparently there's multiple. This is expressions. We're going to get to this once we have finished our basics. There's also this and this. Fortunately, these are pretty short pages. We need to finish this right now. So first we need to go to group by and aggregations. How long is this? Oh, there it is. So we are done with filter. Filter was a interesting topic. Now we are going to group by. Okay, in the context group by, give me a second. There. In the context group by, rows are grouped according to unique values of the grouping expressions. You can then, dude, okay, quick thing, real quick. I have done multiple projects in pandas. Like, dude, I've done multiple, I don't have like, crazy experience in pandas, but I've done multiple projects. So I have some experience. I have a certain amount of knowledge in pandas. Okay. I would always find myself coming back to the documentation to reference stuff and relearn their their own way of doing, like they had designed their entire API in a specific way. They had designed their they designed a certain way for you to work with data frames. Um, and that way, how do I even say this without making it sound like I'm shitting on pandas? That sounds wrong. Pandas library. I mean the pandas library. How do I make make how do I make this not sound like I'm shitting on the pandas library? Um, okay, let me put it in this way. I'm still a beginner in polars, and somehow I'm much more confident that I'll be able to think of solutions for various things in polars compared to if I was doing the exact same thing in pandas. I I don't know how to explain it. Just something about the way that their API is designed, the way that Polar's API is designed, and this simple expression kind of system. Like you set up these expressions, and the expressions they get evaluated later on in the context. Within the expression, you can do a bunch of like very complex filtering and selecting, and now apparently even grouping and um, I'm sure there's more stuff. I have to see what comes under aggregation, but there's a bunch of very complex things that you can do with expressions. So you can like design these expressions, and they don't get evaluated at that same time. They only get evaluated once they're passed into a context. And that's incredibly powerful. That's like creating SQL queries, um, and having them, sit in a variable, so you can then pass them once they're needed. And there's also just something about their API just seems very intuitive. Um, a lot more. I don't know. I don't know. Something about it is a lot easier to remember, a lot easier to understand than what I was able to do with pandas. Because with pandas, I would understand it and I would practice it. And as long as I'm continuously practicing it, yeah, I'll remember it. But if I step away from pandas for even a couple of weeks, I'm going to come back and then I'm going to have to look at the documentation again. It's just something about their API, the way that their API was designed. That's what it resulted in for me. But I feel like I'm not going to have that trouble with Polars. And I have a strong feeling that maybe Polars was designed to address similar issues in other libraries, including pandas. Yeah, I don't know, maybe that's just me. Actually, you know what? I'm gonna open up a new conversation with Gemini about this and see if Gemini can tell me like some history about polars. Hey, so I'm currently learning the polars library in Python. Prior to this, I used to use pandas. Um, I'm not an expert in either of them. However, I'm very much, hold on, yeah, I'm very much a beginner in, I'm very much a beginner in polars. While I have done a bunch of projects in pandas, something that I noticed with polars is that even though I'm a beginner, the API seems very intuitive and easier to wrap my head around. And I feel like if I come back to this a couple weeks later, I'm still going to remember how to do stuff in polars. But with pandas, um, it would be really easy to quote unquote lose practice. And then I have to refer to the docs again. This makes me wonder, was polars designed to address possible, for lack of a better term, grievances with pandas and similar libraries? What's the history there? It is not just you. What you're feeling is a very common sentiment in the data science community. While pandas is the quote unquote legend that paved the way, it grew organically over a decade, which led to some architectural quirks that can feel like mental gymnastics. Polars was absolutely designed with the lessons learned from pandas in mind. Its creators, Richie Vink, its creator Richie Venk started the project around 2020. Holy shit, it's only 6 years old. That's crazy. Around 2020 specifically to to address the performance bottlenecks and API inconsistencies found in older tools. The mental model shift. Pandas was built on top of NumPy, which was designed for mathematical arrays, not necessarily relational database style operations. Polars, however, was built from the ground up using Apache Arrow. Okay. Why Polars feels stickier? That's an interesting way to put it. The reason you feel like you won't lose practice is in Polars is due to its expression API. In pandas, you often have to switch between different syntaxes depending on the task. So df column is for selection, df.groupby.aggregate is dictionary based aggregation, df dot so and so. Okay, so there's different syntaxes, there's different ways of doing things. In polars, almost everything follows the same flow. Df.select, df.with columns, df. or df.filter. Inside those functions, you use pl.call. Once you learn how to write one expression, you've essentially learned how to write them all. This Lego brick, quote unquote, Lego brick philosophy makes the API much more intuitive to store in long-term memory. Okay, solving the quote-unquote grievances. Richie Vink and the Polars team targeted three specific Pandas pain points. The index. Pandas uses a dedicated index column. While powerful for time series, it it often causes setting with copy warnings. I've actually had that. Yeah, I've had that warning a couple of times. Warnings and confusion for beginners. Polars removed the index entirely. You know what? That did not occur to me until now that I have not seen an index. Because usually there would be um, some sort of index mentioned. There would be like an index column, even after you um, read a CSV file, it adds an index column. You can also specify whether you want to ignore the index column um, from the CSV file. But then when it's printing it out, it's going to add its own index column. And also, when you're writing the data back to the CSV file, you can decide whether you want to ignore the index column or also write the index column. But here so far with everything that I've done, I am yet to see. We should stick with this. Yeah, we should stick with this. So we're gonna do it like this. Okay. Um, you know what? I should. Where are we here? Here I should do this. Let me activate the environment here. Activate, and then Python 3.13 pi oh what am I doing? Pi o1 dot pi. Okay, that's our CSV, and then we pipe that into this. So then we don't need to do this. We can just do it in this way, and then I can switch to this and rerun it. Awesome. Great. Okay. All right. Yeah, Polars removed the index, treating data more like a SQL table. Okay, performance. Pandas is single threaded. If you have a 16 core, if you have 16 CPU cores, Pandas only uses one. Polars is written in Rust and is multi-threaded by default, meaning it uses all your hardware power without you having to ask. Okay, memory efficiency. Pandas can often require 5x to 10x the RAM of the dataset size. Polars uses lazy evaluation to look at your entire query. Um, wait, Polars uses lazy evaluation to look at your entire query. Realize you only need 3 out of 50 columns and ignore the rest before the data even loads. That's interesting. I should look into how that whole that whole evaluation thing is working. Okay, the verdict. Pandas is like a Swiss Army knife that has had 100 different tools welded onto it over 15 years. It's powerful, but you're bound to cut yourself occasionally. That's crazy. Okay, but you're bound to cut yourself occasionally. Polars is like a precision engineered scalpel. It's narrower in focus, but much more predictable and faster. Since you've already noticed the benefits of the API, you'll likely find that your translation, quote unquote, translation time from thought to code will drop significantly as you stick with it. Awesome. Then I'm going to stick with it. Okay, so now we're going to get back to group by. In the context of group by, no, in the context group by, rows are grouped according to the unique values of the grouping expressions. You can then apply expressions to the resulting groups, which may be of variable length. Okay, when you use the context group by, you can use an expression to compute the groupings dynamically. Okay, so this is probably going to be the first time here that we are dealing with possibly multiple different data frames, because they did mention different sizes. Or it could be, because like usually what we were dealing with so far was there would be like one series whose length would be considered as sort of the master length, for lack of a better term. It would be considered as like the master length. And then if you have any scalars, all those scalars would be broadcast to that length. And you can't have any other series of a different length in there. You have to like somehow fill in the values to make it of that specific length that the data frame is expecting. Here though, we might have something different going on. Let's see. Okay, result equals df dot group by so and so, so and so. Okay, let's do this. Result equals, I deleted the entire thing. Okay. Group by, okay. PL dot call birth date dot dt. Oh, dt. Oh, here's something else that I learned yesterday. Apparently, we have access to multiple namespaces within within these column expression kind of things. So, for example, if I did something like okay, let's do expression o1 equals pl dot call. I'm so used to typing pd because of pandas, but okay, pl dot what call pl dot call, let's say name dot, and now I can do str. So str is also a namespace. Within the str namespace, we have a bunch of string related functions, right? Let's say I do split. So we are splitting it based on a certain character, and this also returns an expression. So let's say we want to split um, based on a space, because if you look here, our names are all, they have spaces. So we have first name and last name. What was I going to do? Oh, yeah. So what split returns is usually a list. In our case, is it specifying here that it's going to return a list? Because it's specifying that it's returning an expression, which is fine. We know it's going to return a list, but like within the expression, I'm guessing that is also just considered an expression. Where's the return thing? Okay, it says it returns expression of data type string. Well, we know that this is going to be a list, so we can use the list namespace to get the last item from it. And this will be our last name of uh, of the person. So we can do something like, okay, let's cut this. Wait, that cut all the way to the end. Okay, let's cut this and bring it here and change this to select for now. And let's say last underscore name equals oh, I just deleted that whole thing. Never mind. we can rewrite the thing. That's okay. pl.call name dot str dot split split by space, and then because we know this is a list. Actually, I didn't know there's a last function here as well. Get the last value. Oh wait, wait, no, this returns a string, right? Still, we're gonna do list dot last, and let's delete this, and let's see what we get here. This is our last names thing, our last names list. Why was I doing this? I forgot why I was doing this. Well, this is one of the other things that I learned. Oh yeah, I was talking about this because I remembered this namespaces thing by looking at DT, because DT is something that we have in there for year. Okay, let's do this, and okay, group by next line pl.call birth date dot dt dot year, and then divide it by, actually no, we're getting the remainder there. What does that count as? Does that count as a division operator? Because like if we try to apply arithmetic precedence, multiplication happens first. So we would then do 10 multiplied by 10, which is 100, and then the year, what do we even get there? Okay, let's open up Python here and do, so we get the year, right? 2026 by this. What is this operator? I can't remember what this operator is. Hold on. Let me ask Gemini. In Python coding, what is the so and so operator, and how is it different from this operator? In Python, both operators are used for division, but they handle the result differently, especially when it comes to remainders and decimals. The breakdown. The slash operator, which is for float division, this is your standard division. It always returns a float, a number with the decimal point. Okay. Okay. Even if the number, even if the even words, even if the numbers divide evenly. And then we have double slash, which is floor division. This performs division and then rounds down to the nearest whole number. Oh, I thought this is a remainder. I think remainder might be the modulo operator. I think remainder might be the modulo operator maybe. Is it? No. I don't I don't know actually. Hold on. Cuz like in terms of division, I don't know what part of the division modulo is returning exactly, but I do know the different ways that modulo can be used, and one of the one of the main ways that I've always used modulo is when I need a value to sort of wrap around itself. So the value has to start from zero, and I need the value to sort of wrap around itself. Then I'll use the modulo operator. So let's say um, what's a good, how do I give this example? So okay, if we are saying 50, I don't remember which side what has to be on, so I'm gonna say, um, yeah, maybe it has to be the other way around. Is it because these are not integers? Let's make them integers. Okay, and then move this. Okay, so that's going to be 5. No, hold on. I need a way to I need a good way to demonstrate this, because what was a good way to demonstrate the use of the modulo operator? There was a way to demonstrate the use of the modulo operator. So if we do this, we get 0. We get 4.1. Okay. 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 But if we do it in this way, 5.1, 0.2. Okay, what if we're doing 6? 6.2, 10.2. No, that's just not doing anything. What was dude, I'm forgetting the use of the modulo operator. How was I using the modulo operator to wrap the value around? I guess this is where it becomes useful to understand how the thing is working. Um, okay, let's give this, I don't know, 9.1, 9.5. That goes down to 2. Hold on. I'm doing Python coding. I've used the modulo operator in the past to sort of wrap values around themselves, but I can't seem to remember how to use it now. Okay, it happens to the best of us. The modular operator is one of those tools that feels like magic until you step away from it for a week. Okay. In Python, the modular operator returns the remainder of a division. Okay, so this returns the remainder. When you use it to wrap values, you are essentially constraining the number. You are essentially constraining a number to stay within a specific range, um, from 0 to n minus 1. Okay, right. So at least I got the 0 part right, that it has to start from 0. And I got the other part right as well, which is that it's up to whatever range we specify. And, well, minus 1, because once we get to that n plus 1 part, it wraps back to 0. Um, Now I need to remember how to do the calculation. How to wrap this? Okay, value modulo range limit. So our range limit is 50. Our range, oh, the, okay, I just remembered it. The value is supposed to be bigger than the range limit, and that's how it's going to be wrapping it. So, for example, if I give a range limit of 1, okay, I'm going to say 1.25 modulo, um, where's the modulo? Here, modulo 1.0. Notice how it says 2.5, right? If I increase this to 3, now it says 3 point, now it says, did I say 2.5? No, notice how it says 0.25, and now notice how it says 0.35. I'll increase this to, let's say, 8.5. Okay, cool. And 9.5. Now, if I increase this to 2, it wraps back to 0. And then if I do 2.5 modulo 1, then we get, again, 0.25, and it just continues like that. Man, I forgot how to use the modulo operator, but yeah, this is how you do the whole wrapping thing. Um, how did we get to this point? Oh, the slash thing. So the slash thing is not, the slash thing is apparently just rounding it. Okay, how floor division works. The term floor, wait, if it's a floor, is it like the floor and seal thing? Because okay, floor and seal are two other things that I always forget. Um, from what I remember, if I'm just gonna guess this, floor is um, the greatest integer smaller than x. So if we test that out here by importing math, math.floor, and we say 2.5, it should give us 2. And so seal would be the greatest integer or the smallest. No, seal should be the smallest integer that is greater than or equal to x, which should be 3. I spelled seal wrong, which should be 3. Okay, yeah. So floor is the smallest integer. No, floor is the largest integer, which is less than or equal to x. Largest integer less than or equal to x. And seal is the smallest integer, greater than or equal to x. We can test this out. Math.floor returns the floor of x as an integral. This is the largest integer less than or equal to x. And then we have seal, which is the smallest integer greater than or equal to x. Okay, all right. Glad I managed to remember it this time. Okay, how floor division works. The term floor is important because of how it handles negative values. It doesn't just cut off the decimal, which is what I was about to ask it just now. I was about to be like, okay, is it basically just rounding off the values? No, it moves towards the smaller number on the number line. Oh, so it's an actual like floor function. Okay, so positive result. Hold on, this makes a difference in negative numbers. So for a positive result, if assuming this is an actual floor operation, positive result, sorry, had to stretch for a bit. Um, so 7, let's do this while, you know. Okay, so floor division, 7 floor divided by 2 is 3. So 3.5 becomes 3. Negative result, negative 7 floor divided by 2 gives us negative 4, which is interesting because we are talking about the largest number, the largest integer, which is smaller than or equal to x. But in this case, in the case of negatives, it works a little differently. Okay, all right. Okay, all right. Pro tip, if you need to find the remainder that was left behind, by the floor division operator, you would use the modulo operator. For example, so-and-so gives you 1. Oh, wait, so if we do this, we get 1. Oh yeah, this is supposed to be our yeah, okay, never mind. Okay, you know what? I just realized that I'm focusing on something that does not need to be focused on. Let's carry on here. Okay. Whatever this calculation is supposed to be, and then we give it an alias, which is our new, um, I'm assuming our new column name. Great. And then we aggregate. I need to see what that means exactly. Wait, what's the issue here? DT year. Okay, okay. Um, I'm confused about this. pl.call.dt.year. Okay, dot alias. Why does this not contain... Did I? No, am I missing Oh, I missed this. Wait, there's still an issue. Name, PL call, aggregate, okay. No, that's still an issue. That wasn't the entire issue. Hold on, let me trace all of these again. Oh, that was the issue. My mistake. Let's run this and see what result we are getting. We do not get a result. Oh, it doesn't support nested. Yeah, okay, okay. That's fine. Um, that is fine. We can just have it print this thing out. Actually, let's just do this. Result, and yeah, then we can have our result. Okay, this is our result. I wonder how this would look in TW. Okay, that's not gonna work. What about bat? No, the values are already wrapped before it can be... how can I do this? Uh okay, I can look into that later. I need to understand what's going on here. Okay, after using group by, we use aggregate to apply aggregating expressions to the groups. Since in the example above, we only specified the name of a column. we get the groups of that column as lists. We get the groups of that column as lists. So these are lists of what names? Yeah, it's saying aggregate by column name. Okay. We can specify as many grouping expressions as we'd like, and the context group by will group the rows. Will group the rows according to the distinct values across the expressions specified. Here, we group a combination of decade of birth and whether the person is shorter than 1.7 meters. Okay, so we have group by, fine, let's try adding this. So this is an extra thing here, pl.call, height less than 1.7, alias short. Okay. That's not what I was going for. This is what I was going for. Okay, interesting. So we are creating columns. We are creating new columns for each grouping. No, we are creating new columns, and each new columns each element of the new column is for one of the groups. How do I even say that? I'm not sure how I'm supposed to say this, but like we are creating these groups, and then for each of these groups, we have a decade value and a short value. Yeah, that's a good way to put it. I need to explore this this concept of grouping more to understand exactly what is going on here, what is being returned. Okay, the resulting data frame after applying aggregating expressions contains one column per each grouping expression, right? One column for decade, one column for short on the left, and then as many columns as needed to represent the results of the aggregating expressions. In turn, we can specify as many aggregating expressions as we want. Okay. Sorry, zoned out. Okay. Um, right, so we can do aggregate pl.len. Okay, so then we can add in aggregate um, as many things as we want, right? So we can say, I don't know, this, and then we come here and we have that value. Okay, okay. We could try, I don't know, pl.call, height dot, is there a square? There's a square root. Oh, yeah, square would just be this. Yep. Oh, that's, yeah, okay, I forgot about that. That's not going to be single values because that is being performed on the individual, it's being performed on every single element in every single group. This is crazy, dude. And look at how fast that was. That's crazy. I definitely need to explore this a lot more. I'm gonna need a bunch of time to explore this. Perhaps I'll get Gemini to give me a couple of exercises. Um, yeah, yeah. What more is remaining here? See also, see also group by dynamic and rolling for other grouping contexts. Rolling, I feel like is something I would be interested in if it's a rolling window specifically. Yeah, create rolling groups based on temporal or integer columns. Period, offset. Okay, okay. Different from a group by dynamic. The windows are now determined by the individual values and are not of constant intervals. For constant intervals, use group by dynamic. Okay. Uh, okay, so there's three of these that I have to look into. Group based on a time value or an index or index of type int32 or int64. Okay. Time windows are calculated and rows are assigned to windows. This might be this or rolling. One of the two or maybe both of them would definitely be useful in the rolling window functionality I was trying to create for my content pipeline where I had to um, grab a couple of records, so like transcripts worth of like, I don't know, let's say 30 seconds or 60 seconds worth of transcripts. And within those 60 seconds, there's going to be like a good 20 or 30 records because you have like sentences per record, and sometimes when sentences are long enough, then they get broken up into multiple records, so you're going to have multiple records within 60 seconds. So the idea was we have that 160-second window, and then we move forward or roll forward, I guess, but we roll by 60 seconds. No, we roll by 30 seconds. And that's what we were calling our stride. So um, we, what was I saying? Yeah, so we grab that 60 seconds and then we jump past 30 seconds and then grab another 60 seconds and then jump past 30 seconds, grab another 60 seconds, and so on. That was going to be our rolling window functionality. Um, yeah, and I was definitely going to have to like write my own logic for that specific functionality because we did not have we did not have data that was standard enough that one of the pandas functions could handle it. Like our data had like for each record, for each line in the transcript, there would be a start time and an end time. And I wanted to fit everything into like exactly 60-second windows, 60 or less, but like not more than 60. So I was probably gonna have to end up writing my own logic for that, which to be fair, might be the case here as well. And I don't mind doing that, especially considering how much I like the API in this library. I don't really mind spending the time doing it, and it's also going to be good practice because I am learning polars now, so it's going to be good practice. Okay, expression expansion. The last example contained two grouping expressions and three aggregating expressions, and yet the resulting data frame contained 6 columns instead of 5. Okay, yeah, true. If we look closely, the last aggregating expression mentioned two different columns, weight and height. Polar's expressions support a feature called expression expansion. Expression expansion is like a shorthand notation for when you want to apply the same transformation to multiple columns. Okay, as we have seen, the expression so and so will compute. Wait, I didn't see that. Hold on, where is that? Oh, oh yeah, okay. I just completely ignored what was here, and I added my own lines. Otherwise, I would have seen this. I just noticed this. I didn't know this was a thing. What exactly happens here? Uh, let's do result equals df dot select pl dot call weight and height. So if we are specifying two at once within one call thing, what does that result look like? It's the same as if we did two separate things. All right, good to know. But wait, what happens if I try to do something like this? Yeah, that works as well. That operates on both of the columns then. All right. Okay, what was this saying? Yeah, so we did mean dot name dot prefix average. Okay, let's try that. Mean dot name. This creates an object namespace for all expressions that modify expression names. Name dot prefix dot average. Okay, this will compute the mean value of the columns weight and height and will rename them to average weight and average height, respectively. Okay, so let me try to understand what's going on here. So the name in this case could be a single value or it could be a list. So in this case, it's expression name namespace. This creates an object for all. This creates an object namespace for all of all expressions that modify expression names. See individual so and so. Okay. Now because this is a list, So, or because it's multiple, so prefix would then apply to each of them. That is so interesting, dude. Okay. In fact, the expression above is the equivalent of using the two following expressions. Yeah, that significantly reduces the size of this statement. Okay, in this case, the expression expands into two independent expressions that polars can execute in parallel. In other cases, we may not be able to know in advance how many independent expressions an expression will unfold into. Consider this simple but elucidative example. Okay, wait, this is pl.column, pl.float 16. Okay, no, sorry, pl.float 64, not 16. But still, for pl.column, we are giving a number. How does that work? In fact, not even a number. We're giving a type. How does this, like, what is this doing exactly? Let's add pl.call, pl.float 64. It's just a type. What is this giving us? Wait, what just happened? Why is this giving us weight and height? Okay, yeah, I'm a bit confused by this. Okay, let's continue reading. This expression will multiply all columns with data type float 60. Oh, that's why. So in the wait, print df. So here are we have two columns that are float 64. That's why when we specify a type, then it is essentially pulling all of the columns that are of that type. And because of that, we don't always know what the number of columns is going to be. Okay, the number of columns this applies to depends on the schema of each data frame. True, depends on all of the columns that are in it. In this case, in the case of the data frame we have been using, it applies to two columns. All right. Yep. Yep. Okay. In the case of a data frame, in the case of data frame df2, where's df2? Oh, is that down here? Yeah. Okay. In the case of data frame df2, the same expression expands to zero columns because no column has the data type float, and that just gives us an empty thing. Okay. All right. It is equally easy to imagine a scenario where the same expression would expand to dozens of columns. Next, you'll learn about the lazy API and the function explain, which you can use to preview what an expression will expand to. Which you can use to preview what an expression will expand to given a schema. I'm definitely interested in that. Hold on. I'm interested in that. So we'll do this and do that. And we're going to say expression O1 equals pl.call. And I'm glad that I learned this thing. Weight and height. Right, so then we'll do print expression. Is this how we do explain? That's not how we do explain. How do we do explain? I just want to, real quick, just want to get an idea. Okay, previewing the query plan. Q.explain. What is Q here? Okay. Q is what we read, I guess. Oh, so the schema, not of our expression, but of the data set that we just read. Which you can use to preview what an expression will expand to given a schema. When to use which, okay. All right. Yeah, this output that I'm seeing here is similar to what I got when I accidentally used scan CSV. I still need to look into what scan CSV does compared to read CSV, because read CSV is reading all of the data, but scan CSV apparently only reads some like very specific data. It's not meant for reading the entire data set. Yeah. I'll look into this. Okay. You know what? I think that's going to be it for today's stream. Um, yeah, dude. I'm glad that I got into Polars. I'm gonna do more of this Polar stuff off stream. I do want to at some point set up that YouTube upload script because I am constantly uploading the videos. So I feel like if I automate things a little bit, it'll things will become a little less hectic for me in terms of uploading. Because currently I have to like open up that UI, I have to open up that page and then click create and do the upload thing and set all of the metadata and stuff. It would be much easier if I was able to set the metadata from within the terminal. So using something like NeoVim and then point a Python script or point the YouTube upload Python script directly to the specific video file that needs to be uploaded. So then that script can read the metadata from a file which I've edited, and it can read the video file and then just perform the entire upload. This would make things so much easier for me, considering my terminal based workflow. Things would become a lot more streamlined, let's say. Yeah, you know what? I need to set that up. I need to set that up quick. Now that I've thought about it, that would make the process of uploading so much easier for me. So I need to set that up quick. I think what I'm going to do is I'm going to go and do research on the YouTube upload script after the stream. I also need to set up that mechanism for the keyring functionality thing. There's like a keyring kind of service or vault or whatever it's called within operating systems that is meant for storing credentials. And I want to use that to store my API keys so I don't need to worry about things getting exposed. The problem is, I think the YouTube upload script requires you to set that value when you're running the script. So like I'm gonna have to see if there's a way that I can like maybe load the value in before I call those functions, and then I'll be able to pass it in. So then I can load the value from the vault, and again I won't need to worry about accidentally exposing the API keys, the API the tokens. But yeah, that's going to be it for today's stream. I won't be raiding anyone. I'm kind of tired. I need to go do stuff. I need to then also cook my food and eat. Um, so yeah, I don't think I'll raid anyone today. Once I'm done with all the stuff I need to do, I'm gonna quickly start doing research on the YouTube upload script so I can get started with that. But that's going to be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.